just going to cover a bit about around normalisation. We've gone through the slides and stuff that explains what normalisation is, but practically what difference does it make? So I've knocked up a small example that will give us an idea. So first of all, we're going to do the usual thing of checking if a table exists before we're dropping it. And off the back of it, there's some also additional reading material in here around data types and stuff like that. We're going to create a table called TBL denormalize, which is basically we're going to take data from the Adventure Works database, and it's actually set as nvarchar. You'd only really want to use nvarchar if you were using Unicode characters, which we don't tend to use. But the storage of nvarchar is twice that of normal varchar, so obviously one to be aware of if you've got any nvarchar in your tables. So first of all, we'll create the table. Now we're going to actually create some duplicated data, and the way we're going to do this is by using a cross join. We come to a cross join in the joining module, and we go into a bit more detail on it and how it works, etc. We've also created a row number based off this. So I'll just run the query to give you an idea of what sort of data is coming up. So there's a whole host of 320,000 rows of duplicated data, and they've all got an ID again, so let's just insert that into the table. Okay, so 320,000 rows and 40, and we're just going to select some rows out of that table. We're going to aggregate the data. Again, we cover aggregations in a later module, but basically what we're doing is grouping by the name and giving a count of how many there are. So if we just run that through, as you can see, there's 504 rows returned, and for each one it's duplicated 365 times. Okay, so I'm going to create a table to remove the duplicates, and how we're going to actually do that, we're going to hold the unique values in a types table. So again, similar sort of principle, we're creating a type ID, which is the primary key, and it's an identity column which actually increments, starts at 1, increments by 1. Again, we're also creating an nvarchar 50, but this time we've added the unique keyword. This actually will fail if you tried to do an insert which had multiple values which were the same. So we just run that through. Okay. So we're going to use the same query that we ran before with the group by. This time we've actually commented out the count, because all we want to insert is the name column, so we're inserted into the types table the name, and we're grouping by, and just for clarity we're going to add an order by, so they're actually in order. So if we just run that through, 504 rows, if you remember that was what we got before. Let's have a look how that looks. So the actual unique values in the table, and then we've got a type ID. So what we're going to create is a normalized table, similar sort of principle that we created before, but instead of having actually a value, we're going to actually have the type ID. So if we run that through, and that's done. Now we need to populate that, so what we need to do is join back in using an inner join. You don't need to specify the inner keyword, it works without, but like I said, we'll cover that when we come to the module. So if we just do the insert now. Okay, so following best practices, we're going to add an index onto our foreign key. It's not a foreign key, but it's just a join condition. That will just speed things up. So all we're doing is creating, just run that while I explain what it's doing. So basically we're creating, that's the index name, and we're creating TBL on that table, TBL underscore normalize, on the type ID column. So this is what our data looks like in the normalized table. As you can see, it's just got ID and a type, which relates back to the table we created before. So it's not overly useful until we join it back. What we're going to do, we're going to add some statistics information in. Again, we covered this more in the performance tuning module, but all you need to know is basically this will return some information that will allow us to compare the two different methods that we're using. So we've just set those on. Okay, and the other thing I've added in here is an option recompile, so every time it runs it recompiles it, so we're not getting cached data off the back of it. So let's just run that through. I'll give you an example, and it takes a few moments to actually go through. But if we actually look on the messages tab, it actually gives us some outputs, how many rows, the scan count and the logical read. So this is actually the number of AK pages that it's read and the elapsed time. What I've done, I've mocked these up already. This is running on a different server that I ran it through, so that could be slightly different actually where the pages overlap. So I'll use the values that I've read, that I've gone through on here. So basically this query returns 564. As you can see, it was 561, so it's close. 8K pages, so if we, you might not realize, but you can actually run SQL statements against and it will give you return values. So we've basically got 4512 meg. 8K pages, sorry, that's kilobytes. Make sure that gets updated. Okay, so 4512, which is about 4.5 meg. Remember, it's not huge tables, they're not wide tables. This is just a mocked up example. Let's do the same as well for the other table. Again, messages, logical reads 2400, 2144, which is exactly what we got previously. So this is the denormalized table. As you can see, there's quite a comparison between 564 and 2144. The elapsed time was 1037. And remember, I'm going by these values compared with 1021. So the time wasn't very different, but then again, we're only returning a small amount of data. But the difference in sizes of data is basically from 4.5 meg compared with 17 meg. So if you can start to see already the benefits of denormalizing your data and joining it back through, because you've got to pull a lot less data off disk. Also, if we actually look at the size of these two tables, let's have a look. And you've got a denormalized table, properties, if we go into that one, and storage. You can see it's 16.6, and if we go into the normalized properties, it's 5.2. So there's a big difference when it actually comes to the size of the data on disk, and you've got a lot less disk to bring back. If we do a comparison using T-SQL, because that's what it's all about, of course, SP space used, normalized and denormalized, you can see we get the similar sort of thing that we've just seen. So it's about a third of the size to actually do that. Okay, another scenario for this. Product manager, manufacturer contacted us and said they needed to update the table name. This could be insurance data, it could be anything. What we've got with the denormalized data or the normalized data is, because we're using types, we only have it in one actual place. So all we need to do would actually to be update the actual type table with the value, rechanging the name, rather than with the denormalized data you've got to update every single row. So let's just run those through, and what you can see is on the top statement, logical reads were 2891, so that's 2,891 8K pages compared with 14 8K pages on the bottom query. So there's a significant gain off the back of it. The first query read 23 meg compared with 112 kilobytes.